everyone, I am Usharani. Welcome back to my channel. Today in this video, I am going to explain about the irrational numbers, and next one is fundamental theorem of arithmetic. That third theorem I will explain. In my last two previous videos, I already explained about the introduction of real numbers, number system, Euclid's division algorithm, and a fundamental theorem of arithmetic. In that fundamental theorem of arithmetic, three theorems are given. First two I already explained in those videos. If you want to watch, please watch those two videos to clearly understand. Next continuation is the third theorem. And the third theorem is, let P be a prime number. Any of the number, if you assume as a prime number, that P divides a square. Whenever it divides a square term, that means square term, then automatically divides a. That is the fundamental theorem of arithmetic 3. Now, just use that theorem. You have to prove that these numbers are irrational numbers. Let us see here. One of the example I have taken where root 2 is an irrational number. It is a very important question. It is already repeated many times in the public exam. So please concentrate on this sum. Now, root 2 is an irrational number. Whenever any other number is given an irrational number, just first directly we can't show that that is an irrational number. So what you have to do? First you have to assume that is a rational number. So root 2 is a rational number. You have to assume that. Let us assume that root 2 is a rational number. If it is rational, we already assumed. Whenever it is rational, then there exist two integers, R and S. Here the condition is denominator should not be equal to 0. Here our denominator we assumed as S. So S is not equal to 0. Now such that where root 2 equal to R by S. Now this we assume as the rational number. If R and S have a common factor other than 1, then we should divide by the common factor. So to get where root 2 equal to A by B. Here where root 2 equal to A by B, here A and B are co-primes. We already divided. Here A and B are co-primes. Co-primes are nothing but both have the common factor 1. Now root 2 equal to A by B. Then we get cross multiply where A equal to root 2 into B. Whenever root term is there on any one side or on both sides. So what you have to do for simplification means squaring on both sides. You write squaring on both sides. Squaring on both sides. Then we get what we are getting here. A square equal to root 2 square is nothing but 2 and B is nothing but B square term. Now here A square equal to 2B square. 2B square is nothing but 2 into B square. Whenever 2 is in the multiplication here, then it comes to this side, then automatically it divides. Then 2 divides A square as well as A also. This is according to the arithmetic theorem 1.6. Now, so 2 divides A square as well as A also. Now let us take here, just take A equal to 2C. Now substitute this A value in the equation. This is equation number 1. In the equation number 1. Now, here in place of A, we assumed where A equal to 2C. Now, here assume in place of A, 2C you write and root 2B. Now, again squaring on both sides. Why? Because here root 2 term is there on RHS side. So, due to that, we have to do that squaring on both sides. Now, 4c square equal to, square means 2c whole square. That means 2c whole square equal to root 2b whole square. 2c whole square. 2c whole square means 2 square equal to 4. C square means directly you write c square. And here root 2 whole square is nothing but 2 and b square term. Now 2 is divisible in this one time, in this two times. So 2c square equal to b square. That means 2 goes to other side, it will become division. So automatically 2 divides b square as well as 2 divides b square as well as b also. Here what we got it here, another common factor a and b. For a and b also, both terms are divided by 2. That means a and b are not co-prime numbers. So here both a and b have a common factor 2. That means this contradiction has arisen. That means here a and b are not co-prime numbers. This contradiction has arisen because of our assumption root 2 is rational. That means our assumption is false. So it is not a rational number. So we can prove that where root 2 is an irrational number. Here a and b have a common factor 2. That means a and b have the common factor 2, means these two are not co-prime numbers. Here a and b are not co-prime numbers. This contradiction has arisen due to our assumption root 2 is rational. This assumption is false. So we can conclude that root 2 is an irrational. So we can conclude that root 2 is an irrational number. So just let us see here once. You have to prove that root 2 is an irrational number. So any of the root terms they will give you. You have to prove that that is an irrational number. So how can you show that? So first you have to assume that the given number, here root 2 is given, so root 2 is a rational. Root 2 is a rational number, you have to assume. Is an irrational number you have to prove, means is a rational number you have to assume. Now it is a rational term. That means it is a rational number, means that is in the form of p by q term. Here there exist two integers r and s. So where root 2 equal to r by s. First you write, we assume this is a rational number. So we have written like this. Now here r and s have a common factor other than 1. Then we must divide by the common factor to get where root 2 equal to a by b. Then cross multiply these two terms. Then you will get a equal to root 2b. Whenever root term if you get on any one side, then squaring on both sides. Squaring on both sides. Then what you will get? Where a square equal to 2b square. Here constant 2 is a constant number. If it comes to the LHS side, then it will divide the term. So 2 divides a square as well as a also. This is according to the theorem number 1.6. Now you have to assume that here take just a equal to 2c. Now take a equal to 2c. Substitute a value in the equation number 1. So now in place of a, just I substituted here 2c equal to root 2b. Again squaring on both sides. Then what you will get? 4c square equal to 2b square. Simplify, you will get 2c square equal to b square. Then again 2 is in the multiplication term. It goes to other side. It will become division. So 2 divides b square as well as b also. Whenever a and b terms are divided by 2, then that means both have a common factor 2. That means a and b are not co-prime numbers. This contradicts the fact root 2 is a rational number. That contradiction has arisen because of our assumption is false. Whatever we assumed root 2 is a rational number, that is a false. So we can prove that root 2 is an irrational number. Next, last topic in this chapter is laws of logarithms. So what are those? First one is a product rule. Second one is a dividend rule. Now first one, log xy base a, that equal to log x base a plus log y base a. Product, it becomes addition, and division, it becomes subtraction. Dividend rule, log x by y base a equal to log x base a minus log y base a. Now log x to the power of m base a equal to, now to the power, this is the exponent rule. Now m log x base a, this power goes to here. Next, fourth one, log a base a equal to 1. Here these two numbers are same, then you will get 1. Next, fifth rule is log 1 base a equal to 0. Here log 1 base a equal to 0. Next, sixth one, last topic is a to the power of log n base a equal to n. These are the important formulas. You have to by heart these formulas. If you by heart these, then we can solve that logarithm sums. Thank you all. Thank you. If you like this video, please like, share and subscribe my channel.